By now, you should be familiar with solving simultaneous equations with two unknowns and with both equations being linear. For an example, the two equations given below. You would have solved simultaneous equations such as these using the method of substitution, where one of the variable is made the subject of formula and substituted into the other equation to eventually obtain the value pair, or by elimination, where the equations are mathematically manipulated and then added or subtracted to eliminate one of the variables, which then leads to the same value pair. In this video, we shall be learning how to solve simultaneous equations with one of the equations being nonlinear and learn the possible scenarios. Consider the two equations given. It is always a good idea to number the equations given for ease of referencing later on in your working. This is equation number 1 and this number 2. First, identify the linear equation. It is usually the one that does not have any powers or exponents in the variable in the equation. If you are not able to identify the linear equation readily, then attempt to rearrange the equation to the form y equals mx plus c. Linear equations take the form y equals to mx plus c, and nonlinear equations cannot be expressed in that form. After identifying the linear equation, make one of the variables from the linear equation the subject of formula. Choose one that is less complicated to derive and handle. In this linear equation, making y the subject of formula is much easier than the x, and the equation is now numbered 3. Next, substitute equation number 3 into equation number 1. In other words, substitute the expression for y into the nonlinear equation and call that equation number 4. Basically, the method of substitution is being deployed. Simplify equation number 4 as much as possible. In this example, equation 4 simplifies to a quadratic equation resulting in two values of x. Next, substitute the two values of y into equation number 3 to obtain the two corresponding values of y. These two value pairs are the two solutions to the simultaneous equations. What that means is that if we were to take each value pair and substitute the values of x and the corresponding y into the two given equations, the equations must be satisfied. That is, the left-hand side must equal the right-hand side. The next question to ask is, why do we get two solutions? To answer that, a graphical approach is required. We can do a simple sketch of the two equations that were given. Equation 2 is linear, and we have proven it by expressing it in the form y equals mx plus c, a straight line with a positive gradient. Equation 1 is nonlinear, and it is an equation of a circle. We have got a straight line and a circle. Three possible scenarios can be presented in this case. It is possible for the straight line not to meet or cut the graph. If that was the case, then you will not have gotten any solutions to the pair of equations. Or the straight line could just touch the graph. That is, the straight line could be a tangent to the curve, the circle. And then you would have gotten only one value pair, that is the value for x and the corresponding y. In our example, we have obtained two solutions, which imply 2 points of intersection between the two graphs. Therefore, it can be concluded that in our example, the straight line cuts the circle, and if it cuts the circle, it should cut at 2 points, and that is why you get two solutions.